Like any star, Betelgeuse will eventually exhaust its core fuel and begin to undergo transformations. It will start to expand, ultimately engulfing the orbits of Mercury and Venus, and coming alarmingly close to Earth. The impending demise of Betelgeuse is unsettling for astronomers, but there is nothing that can be done to avert this cosmic event. The massive star is on the brink of a supernova explosion, with predictions suggesting it could occur tomorrow, next month, or within a few months. While the exact date remains uncertain, one thing is clear. The famous Betelgeuse has reached the end of its life cycle, and its explosion will significantly impact our planet. What makes the potential Betelgeuse supernova so concerning? What would happen if the star detonated today? Join us on this fascinating journey as we explore these questions in today's video. NASA's chief has announced that Betelgeuse is set to explode as a supernova in 2024, and there's nothing that can stop this impending disaster. The warning from NASA about the upcoming Betelgeuse supernova indicates that it could alter the trajectory of our planet and life as we know it. The end of Betelgeuse is looming like a terminally ill patient. This star is nearing its conclusion, and it's only a matter of time before it ceases to exist. For many years, astronomers have been captivated by Betelgeuse, studying its characteristics and the anticipation of its explosion. This dreaded scenario is about to unfold. Betelgeuse is one of the most notable and surprising stars in the Milky Way, having fascinated astronomers and researchers for centuries. Astrophysicists have long been intrigued by this red supergiant star, whose brightness varies between magnitudes 0.5 and 1.6, distinguishing it as a first-magnitude star with a wide range of luminosity. Traditional astronomers referred to Betelgeuse as an orange star, and it was the Alexandrian mathematician, astrologer, cosmologist, and geographer who provided one of the earliest descriptions of this red giant star. Interestingly, even indigenous groups in South Australia have shared oral histories of Betelgeuse's variable brightness for over 1,000 years. However, advancements in cosmology have given us a clearer understanding of Betelgeuse and its properties. This red supergiant star is located in the constellation Orion and is one of the largest stars known. Red supergiants are among the most massive stars in the universe, with diameters ranging from 100 million to 1 billion kilometers, making them some of the largest stars in the Milky Way. If we could position Betelgeuse at the center of our solar system, its surface would extend beyond the asteroid belt, engulfing the orbits of Mercury, Venus, Earth, and possibly Mars. Research estimates Betelgeuse's mass to be between 10 and 20 times that of the Sun. Remarkably, this star is approximately 600 light-years away from our solar system, which is relatively close on cosmic scales. Astronomers were astonished to find that Betelgeuse is less than 10 million years old, making it a young star compared to our ancient Sun, which is around 5 billion years old. Despite its youth, Betelgeuse's size far exceeds most stars in the universe. Researchers have struggled to accurately measure Betelgeuse's precise diameter due to its pulsating nature, which causes its size to fluctuate over time. Additionally, Betelgeuse lacks a measurable edge, as limb darkening causes the star's optical emissions to vary in color and diminish farther from the center. The star is also enveloped by a circumstellar envelope of expelled material, complicating the definition of its photosphere. Its apparent size also changes based on the wavelength used for observation, and atmospheric turbulence further limits resolution from ground-based telescopes. Despite these challenges, scientists have provided estimates of Betelgeuse's width. Another mystery surrounding Betelgeuse is the complex dynamics of its extensive environment. Researchers understand that mass in galaxies is recycled as stars are formed and destroyed, but the process by which mass is lost remains unclear. New insights gained from studying Betelgeuse reveal that its immense mass has contributed to its rapid evolution. Over millennia, a direct relationship exists between Betelgeuse's increasing mass and its evolution. Betelgeuse's impending demise is expected to result in a supernova explosion at any moment. When astronomers first identified Betelgeuse's nearing supernova state, they were already on high alert. A supernova is a powerful and luminous explosion of a star occurring during its final evolutionary stages, or when a white dwarf undergoes runaway nuclear fusion. The progenitor star could either collapse into a neutron star or black hole or be entirely obliterated, resulting in a diffuse cloud. If Betelgeuse were to explode today, its peak optical brightness could rival that of an entire galaxy before fading over weeks or months. The sheer brilliance of this event would either astonish or terrify onlookers. An interesting fact about Betelgeuse is that it is visible to the naked eye at night. However, it is perplexing that it becomes nearly invisible during the early months of May through August because of its proximity to the Sun. Betelgeuse is one of 3 stars that form the winter triangle asterism and marks the center of the winter hexagon. Each year, from early January, the star rises in the east after sunset, and by mid-March, it is visible in almost every populated area on Earth, except Antarctica, which lies south of 8 degrees latitude. On a typical night when twilight fades and darkness sets in, Betelgeuse stands out among the stars. If Betelgeuse were to explode today, everyone would witness its aftermath. The explosion would be as visible as a live-action 3D film, appearing as an incredibly bright point of light in the sky, potentially casting a dramatic glow over the landscape. For over 90 days, shadows have been cast in the evening, as the potential cosmic explosion of Betelgeuse could dazzle like a half-moon, significantly impacting life on Earth. Located just 642 light-years away, Betelgeuse is essentially a neighboring star, and its eventual explosion is inescapable. Before diving into the potential effects of Betelgeuse's supernova, it's important to note that the star's brightness is not constant. This might surprise many, but it aligns with the fact that Betelgeuse is a pulsating semi-regular variable star, undergoing cycles of brightness changes due to fluctuations in temperature and size. In 2019, Villanova University astronomers Richard Wasatonic, Edward Ginnen, and amateur astronomer Thomas Calderwood first noticed Betelgeuse's dimming, initially thought to be an illusion due to its extraordinary nature. After conducting various tests, they confirmed the dimming was indeed real. They estimated that a combination of Betelgeuse's normal 5.9-year light cycle and an unusually prolonged dimming event caused this phenomenon. By late 2019, speculation arose that the dimming might have resulted from an expulsion of gas or dust, or changes in the star's surface brightness. Early in 2020, observations from the Hubble Space Telescope led scientists to hypothesize that the dimming was due to a significant amount of superheated material being ejected into space, cooling, and forming a dust cloud that obscured light from about a quarter of the star's surface. Hubble captured signs of dense, heated material traveling through Betelgeuse's atmosphere in September, October, and November, with other telescopes confirming the significant dimming in December. By early January 2020, astronomers noted that Betelgeuse had dimmed by a factor of approximately 2.5, decreasing from magnitude 0.5 to 1.5. The situation worsened in February, when researchers reported that the star was at its dimmest and coolest in 25 years. This news fueled speculation about an impending cosmic explosion, although NASA maintained a cautious stance. However, brightness began to stabilize around February 17, 2020, with indications of re-brightening observed by February 22. Further investigations on February 24 suggested that large grains of circumstellar dust could have caused the dimming, although it seemed the dimming episode had ended. Late reports from NASA indicated that Betelgeuse had started dimming again, with the American Association of Variable Star Observers confirming that it had dimmed by approximately 0.5 magnitude since late January. News of this development in March 2024 sparked heightened anticipation about what might come next. Despite the striking fluctuations in Betelgeuse's brightness, the primary concern remains the star's inevitable explosion. The possibility of Betelgeuse's supernova and its potential effects on Earth has generated widespread anxiety, with theories about the event's consequences circulating. However, astronomers have reassured us that life on Earth is unlikely to be harmed. Declassified documents indicate that Betelgeuse's explosion could occur within 100,000 years, suggesting that it may be centuries before it actually happens. While this reassurance is somewhat comforting, some astronomers outline potential consequences should Betelgeuse explode during our lifetime. Its brightness would surpass that of any other star or planet, releasing energy equivalent to the Sun's total output over its entire lifetime. This immense radiation, including gamma rays, X-rays, and cosmic rays, could significantly affect Earth's environment, potentially damaging DNA, causing mutations and increasing cancer risks. Nonetheless, studies suggest that our atmosphere may protect us from the majority of harmful radiation emitted by the supernova, implying that the impact on life could be minimal. However, the increased brightness of the explosion could disrupt nocturnal animals that rely on darkness for hunting, navigation, and communication. For instance, owls, which depend on night vision, might struggle with the enhanced light, affecting their ability to hunt and evade predators. Similarly, fireflies, which use bioluminescence for communication, could face challenges as the supernova's brightness interferes with their signaling, possibly altering their behavior and mating patterns. The explosion's brightness could also disrupt local ecosystems, with increased light pollution potentially affecting bird migration patterns and altering insect behavior, thereby disrupting ecological balances. Models assessing the supernova's impact suggest it could lead to temporary changes in the ozone layer and influence climate patterns. Beyond environmental consequences, Betelgeuse's explosion presents a unique opportunity for astronomers to study supernovae more closely and gain insights into the life cycles of massive stars. For now, we can only await the unfolding story of Betelgeuse's supernova, hoping that future cosmic phenomena will honor its legacy.